All right, our next contestant is Mackenzie Bowden. She is pursuing a master's in sustainable engineering in the College of Engineering, presenting Optimizing Carbonaceous Materials for the Retention and Transformation of Munitions, Constituent Residues. Here is Mackenzie Bowden.
When I tell people I work with explosives, they either think that I'm a mad scientist or that I develop weapons. What I actually study are munitions residues after an explosion. So I look at chemicals entering the environment and how we can remove them. As I'm sure you can relate, it's much easier to make a mess than it is to clean one up. So after devastating accidents during the Vietnam War, the United States military began replacing legacy explosives, like TNT, with a new class of insensitive high explosives. These new compounds are less sensitive to heat, shock, and accidental detonation, which makes their use safer for military personnel. The problem is that the new compounds are much more water-soluble than their predecessors. So this means they can easily migrate from soils into surface and groundwaters, and their toxicity, combined with that phenomenon, contributes to a huge source of environmental contamination on military testing ranges. For this reason, it's critical that we find ways to retain those compounds, minimize their transport, and then promote their destruction. To do this, we've developed an approach using carbon-rich materials like activated carbon and biochar to simultaneously retain and then destroy those residues. So biochar is a type of charcoal produced from pyrolyzing or burning biomass. So our biochars are made from wood or grass, and they're pyrolyzed at a range of temperatures to optimize their structure. This is important because the structure of the material directly influences the type and the rate of chemical reactions that can be facilitated by that material. So first we use biochar to facilitate adsorption and remove those residues from the environment. Now adsorption is a separations process in which a contaminant is removed from a liquid phase and then accumulated on the surface of a solid. This is that exact same technology that's used in a Brita filter to remove contaminants from drinking water, but here we're using the biochar to remove munitions from environmental media. We can also use biochar to facilitate alkaline hydrolysis and actually degrade those compounds. So alkaline hydrolysis, hydro meaning water, lysis meaning to break, is a chemical reaction in which those individual bonds between the atoms in a molecule are broken apart using water. And this occurs at high pH or alkaline conditions. So for us, those munitions compounds are actually degraded, those bonds are broken, and we produce smaller, less toxic byproducts as a result. Once we've optimized the structure of our biochar to simultaneously retain and then destroy munitions residues, we can apply it topically, kind of like a fertilizer, at the source of contamination on military testing ranges. The final product will be inexpensive, easy to deploy, and can ultimately mitigate the harmful impacts of munitions residues on both human and environmental health. Thank you.
Thank you, Mackenzie, for that presentation. Now, I understand that you are an amateur landscape and nature photographer.
Mm-hmm. Yes.
Now, I've only been graduate dean for a few years, so I guess I'm an amateur dean.
Okay.
Can you tell me about what the most unique landscape is that you've ever gotten a good snap of?
Ooh, so it's probably a toss-up between two. Mm-hmm. Probably my favorite photo is of the most volcanic region in Indonesia. So it's the most active volcano currently from the summit of the volcano next to it.
Was it erupting when you took the picture?
It was, but you can't see anything in the picture.
Fantastic. Thank you so much. All right, I think Dr. Kaufman may have some comments for you. Dr. Kaufman?
Yeah, so as dangerous as it is to be making confessions, I have to say I'm very closely related to your subject matter, because I remember as a high school student, myself and my friends used to enjoy making small explosive devices, particularly those that could be set off underwater. So I feel a certain affinity to what you were talking about there, although I must admit that the correlation between landscaping and explosives seems like a bit of a stretch, but I definitely enjoyed your presentation very much.
All right,
Thank
fantastic. Thank you so much, Mackenzie.